Okay, and this is going to be another part of my code for FTC series. This one we're going to be focusing on subsystems. So basically what subsystems are supposed to do is it's a different control mechanism that allows you to control different parts of your robot simultaneously and split your robot into multiple pieces so it's easier to control. So how we're going to start this is we're going to go into our subsystems over here and we're just going to go new Java class. And we're just going to call this one ARM subsystem. And basically, we're going to do a robot that has, we will have an arm and then have a claw. Just like a simple, super simple robot there. So first what we're going to do for ARM subsystem is we're going to add our constructors. So I'm actually going to turn off Copilot because I don't want it working right now. There we go. All right. So let's say we're going to have one motor. So let's just set up a DC motor. We'll just call it M1 is equal to null. We'll have to import that class. And then what we can do is we can say, okay, public ARM subsystem. We're not going to take in DC motor one. We're going to take in a hardware map. Okay, that was weird. We're going to take in a hardware map. And just call it HW map. We're going to take in a Boolean auto, just checking if we're in autonomous mode or not. And then we're going to set a Boolean up here. Auto is equal to false automatically. And then what we'll do is we'll say, okay, this dot auto, which calls this one up here, is equal to auto. And then we'll set the motor up. So M1 is equal to hardware map dot DC motor dot get. And you can do this however you want to initialize it. I'm going to do the hardware map dot get DC motor dot class M1. And then this is also where you would reverse motors in comparison to where we would do it in hardware config, where we set all of this up right here. So this is basically the same thing for our ARM subsystem. So now what we're going to do is we're going to set up our update function. So what this does is this is the function that you're just always going to call no matter what. So this is what's going to do everything. So we're just going to say, okay, we want to power everything. We'll write that function in a second. And then that's really all we need there. What else we'll add is we'll add a public void telemetry just to report telemetry from the system. So in telemetry, we're going to take in a telemetry parameter because we don't have access to telemetry anything in here. So we'll just say telemetry dot add data, and then we'll just add how much power is being sent. Next, what we'll do is we'll add a power mechanism. So what we're going to have to do first is we'll just go up here and add a double M1 power is equal to 0. And down here, we'll go public void power. And here, all we're going to do is go M1.setPower, M1 power. Okay, so that's really the basics. What else we'll do here is we'll add a just a simple public void set M1 power, and then give it a double power. And all this is going to do is we're just going to say, okay, yeah, we want to set the power. We can also just completely neglect this and just in other programs just use M1 power is equal to this or whatever. So that's going to be the main of what we do there. So now that we're done with this primary class, and this is very, very bare bones for right now, just because we don't really have anything else to add. So in here, you'd add everything else you want to, like if you have PID, if you have encoders, if you're tracking anything, this is where you put it. All your autonomous modes, or all your autonomous functions for the ARM would go in here, and then you can just call the function. So we can just say public void auto1, and then just, in another function we'll say, or in another program we just say, okay, subsystem.auto1, and it would do everything inside this function, just making it really easy for us. So now we'll incorporate this into hardware config. So what we're going to do here is we're just going to go up here to the top, or I'm going to guess about here. We're just going to go public ARM subsystem. ARM subsystem is equal to null. And we're just always going to primarily set it to null. We're going to call this ARM sub. And we're just going to set it to null because we don't want any value yet. Now, inside of our init robot, this is where we're actually going to want to implement everything. So we're going to go ARM sub is equal to new ARM subsystem. And we have a hardware map. And then we're just going to say false because we know we're not in auto because we're in hardware config. Now, this will be different if we're in, where is it? If we're in our auto config, because then we're just going to want to say, okay, init auto, we might want to just add a true in here, and then go back to our super and add a auto parameter. Then we'll add that here, and then we'll add that here. And then we'll add that here. And then we're good. So it's still giving me errors. Why is it giving me errors? Okay, that's fine. So it's just saying, okay, in teleop, yeah, we're not in auto. So we're good there. Back to hardware config. Oh, yes. That was dumb. There we go. So now we have that ARM subsystem implemented. And now at any point we can go ARM sub dot, and then we have power, we have update, and we have telemetry. So really in this case right here would be a good time to talk about where private actually comes into play. Because since we always call update, we don't need power to be public. So we can just go private, and now we can see that from ARM sub dot, and now we only have update and telemetry. So we're all good there. Next, what we're going to do is in our build telemetry function, we'll just call ARM sub dot telemetry, and then add in our telemetry object, and we're all good there. Down here, what we're going to do is we're going to add ARM subsystem dot update, and we're actually going to drag this all the way down to the bottom because that's the last thing we want to happen. And then we'll say in here if op mode dot gamepad dot let's just say a, just say that. We're just going to go ARM sub dot and we did not make that public, so we can't access it. So we'll go back and we'll add public double m power, m1 power is equal to 1.0, and there we go. Else we'll just say ARM sub dot m1 power equals 0.0. And then it'll automatically, in update, it'll automatically power that to the correct value. So that's the basics of an ARM subsystem. Now we are going to make a claw subsystem. So we're going to go back and we're just going to add a new Java class and call it claw subsystem. All right. So claw subsystems are generally more complicated just because you have different states. So this is going to go back to state machines, where we have a bunch of different switches. So we're going to go private final servo, and we're just going to call this claw servo. And we don't want that. I don't know why I added that. But yeah, we'll import that class. All right. So now what we're gonna have to do is we're just gonna have to add a bunch of functions. And actually, I'm gonna remove the final, and we're just gonna add equals to null to follow what we've been doing this whole time. So now we'll add a public class subsystem with class servo is equal to hardware map.get servo.close. So the normal way we define these classes. And then this one needs to take in a hardware map, as we've done before, and just call it HW map. And we'll just go HW map.get servo.class with the name claw. Okay, we're all good there. Now, this is where we'd also reverse, as we've done in all the other ones. Also in here, actually no, not in here. Now what we're gonna do is we're gonna add a bunch of states. So we're only gonna do this for one, but we're gonna add a public enum claw state. Remember, you can call this whatever you want to. We'll add open, close, and idle for the state. And then we have to add a private claw state, and then set it to our initial value, which is going to be idle in this case. Now what we're going to do is we're going to add a public void, and we're going to set claw open. And all we're going to do in here is just go claw state is equal to claw state.open. We'll add a close for that one too, and we'll also add an idle, though you probably won't need it. Alright, so now this would be the same process for doing it for anything else, for doing it for any other servo. So now we're going to add a public void, and then update. So you'll notice I do this for every subsystem, and that's because it makes it very consistent and very easy to track. We're going to switch on claw state, and then we're going to say, okay, if on the case that we are open, we want to open the claw, we're just going to set claw servo.setPosition to whatever you want it to be. This is really just more on your robot. And then when it's idle, we won't do anything. So what this does is it makes it so we only set power to the servo if it's actually supposed to be doing anything. So that makes it to where we kind of have just a little bit more, we're more power conscious, we're not going to destroy the robot. And then as we would have done in other scenarios, we add a public void, telemetry with a telemetry object as our parameter, and let's just go telemetry.addClawState. So you'll notice that we don't have to update it because we update it in hardware config solely. So now, as we just did with ARM subsystem, let's add the claw subsystem. Public claw subsystem, claw sub equal null, and then we just add it in here with hardware map as our parameter. And next, what we're going to do is in telemetry, claw sub.telemetry. You can also see in here we don't have an update because we update it right here anyways, so it doesn't need that. Now here we're going to go claw sub.update, and it's just going to control all of our claw states. So you can add as many of these as you want. It's really just going to be down to whatever design decision you want to do. And next we'll add if opmode dot gamepad1 dot b. We'll just say, okay, if we do that, claw sub dot set claw open, and it'll open the claw. We can add other things. Let's go else if op mode.gamepad1.x. We'll just say, okay, if it's x, call sub.set clock. And there we go. That's really all you need to do for that. You could add the last case, which would just be, okay, we have our open close else call sub.idle, and then we're good there. It's super easy. It'll automatically set it to idle anyways if you're not pressing anything, which just doesn't do anything, so it won't break your program, it won't restart it, won't do anything weird. So yeah, that's the basics of subsystems. If you wanted to add a PID to this, it would not be that difficult, because in ARM subsystem, you could have your PID in here, and I'll just show you kind of what that would look like in my own project. So it would, it would have our regular stuff, PID motor, which is a thing that I'll show later on, but it'll have all these different things, our PID coefficients, and then when we update, we also need to update the PID, which I just do for a config reason, so we can change it on the fly, which I'll show in a little bit, and then power set targets, check if it's at target, and then roadrunner functions. That is the basics of subsystem implementations and why subsystems are good for your program, and really just help it be cohesive and easy to use.